Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a further look at finding volumes using the disk method. In the previous video, we looked at finding the volume generated by taking an area bounded by the x-axis and rotating it around the x-axis. In this video, we're going to take a look at taking an area bounded by the y-axis and rotate it around the y-axis. So it's a very similar idea. If we were to take a representative rectangle, we're going to take a horizontal rectangle, and when that rectangle is rotated around the y-axis, here's the representative rectangle, here's a not very straight y-axis. The screwdriver has seen better days. When it rotates, it will form a disc, which is like a flat cylinder, and we know how to find volume of a cylinder. So this is the shape that's formed, but it's laying this way. Remember, when we're working with horizontal rectangles, we have to describe our functions in terms of y, and we have to use the y values for our limits. So if we were to take this representative rectangle, its length would be the x value, which would be a function of y. It becomes the radius. This thickness here becomes dy, which will become the height of our cylinder. We can pull the pi in front of our integral sign, so it will be the integral from the y values of c to d of the radius, which will be f of y squared, radius is squared, times the height, which will be dy. That gives you the volume of a solid formed by taking an area bounded by the y-axis and rotating it around the y-axis. Let's take a look at a few examples. Our first example says, find the volume generated by revolving the area bounded by y equals x cubed, x equals 0, and y equals 2 about the y-axis. So x equals 0 is the y-axis. So it's bounded by the y-axis, as in it's rotating about the y-axis, so we know we're going to use the disk method. We're going to draw y equals x cubed, the y-axis, and y equals 2. And there's only one region bounded by those three functions, which would be that region. It's rotating about the y-axis. So this shape will kind of look like this as a solid, and we're going to use a horizontal rectangle with a radius of, now we've got a function written as a function of x, we have to change that. So if y equals x cubed, x will equal y to the 1/3. So we're just going to take the cube root of both sides. Now we've got a function of y. So this distance, which is the x value, will be expressed as y to the 1/3. We have to write it as a function of y. Here's our formula for finding the volume in this situation. So we just plug in our particular numbers and functions. So it will be from c is 0 and d is 2. F of y is y to the 1/3. This is the x value, which is described as y to the 1/3. So y to the 1/3 squared, the radius is squared, times the height, dy. Again, let's simplify this first. Let's square this because we cannot integrate it until we do that. Now that it's simplified, we can integrate. So that will be y to the 2/3 plus 1 will be 5/3. 1 divided by 5/3 will be 3/5. So it will be 3 pi over 5 times 2 to the 5/3 minus, when I put a 0 in, this whole expression is 0. Now this isn't a particularly nice number, so we are going to find its decimal value, and that's 5.98 cubic units. Let's try a couple more. A spherical water tank has a radius of 18 meters. Determine the volume of water in the tank when the water is 4 meters deep at the center. So we're not given a function, and you will probably encounter a question like this when you're asked to find a volume. So in order to find the volume, we need a function. So if we think about how we can describe the volume of a sphere, the way that we could do that is we could take a circle and rotate it around the y-axis. Then it becomes a sphere. If we were to take this circle and rotate it about the y-axis, it would become a sphere. Now, we need a function. We need to be able to describe this in terms of x and y. And the function for a circle is x squared plus y squared equals r squared. So in this case, we know the radius is 18 meters. So x squared plus y squared will equal 18 squared, or x squared plus y squared will equal 324. So that's that function. Now we've got a radius of 18 meters and the water is only 4 meters deep. So we're talking about this volume down here. So I need a way to describe that volume in terms of an integral. If I were to take this volume bounded by this circle, and this line, and the y-axis, and if I were to rotate that around the y-axis, that would give the volume that I'm wanting to find. So I need to be able to describe that. Because it's being bounded by the y-axis and it's revolving around the y-axis, I'm going to use the disk method and I'm going to do everything in terms of y. So I have to isolate x. So x squared will equal 324 minus y squared. So x will equal, if I'm working in this quadrant only, then x is positive, because when I take the square root, it'll be the positive or negative. But the positive is in this side, the negative is on this side. I'm going to be working with the positive. And it really won't matter because I'm going to be squaring this anyway. So that's the function here. That's my f of y. Now, there's my representative rectangle. I have to know my c and my d. So if my radius is 18 meters, c will be negative 18. And d will be negative 14. Because it goes from negative 18 and it's 4 meters deep. So that's my c, that's my d. Now I can set up my integral. The volume will be equal to pi times the integral from negative 18 to negative 14 of this value here, which I can describe, my x value, which I can describe with this function. So it will be square root of 324 minus y squared. The radius is squared, and then we multiply by the height of the disk, or the thickness, which would be dy. So that's our integral. We need to simplify it first before we can integrate. When we square this, we'll just have 324 minus y squared. So it would be 324y minus 1/3 y cubed. And now we evaluate. I just kept the pi outside, and then I evaluated this at negative 14 minus evaluating this at negative 18. And when I punch all of that in, I get a volume of 837.758 cubic meters. And from that, I can figure out how many liters of water by just multiplying by 1,000. So a very practical application, and one you probably will see in the problems you're asked to do. Let's try one more example. Here's another example where we're given a shape, but we're not given the function or the function that describes that shape, and so we have to do that. It says the nose cone of a certain rocket is a paraboloid of revolution. Find its volume. So although I've drawn it two-dimensionally, this is a solid. So all we know is the dimension 1.2 here and the height 1.2 here. So we have to place this on a graph and figure out what curve describes that graph. So if it's a parabola, we know that the general formula for parabola is y equals a constant times x squared. We can't assume that constant is 1. What I'm going to do is place this parabola on my Cartesian coordinate system. So I know my function is y equals kx squared, and I need to find what k is. I can do that by taking this point here. I know that this line will be y equals 1.2 meters, because that's how high it is. And I know that this point here will be, if this distance is 1.2, then this distance from the center there is 0.6. So that point will be 0.6 for the x value, and the y value is 1.2. If I plug those in, I'm going to be able to find k. So y is 1.2, x is 0.6, so k will equal 10 over 3. I just want to keep it exact rather than a decimal value. So the function that I'm working with will be y equals 10 over 3 times x squared. Now, let's think about our volume. How do we generate that volume? If we were to take this area in the first quadrant and rotate it around the y-axis, it would generate that volume. So therefore, I'm going to use a horizontal rectangle, which means I'm going to use this formula. And I know my c will be 0. I know my d will be 1.2. But I have to write my function as a function of y. Right now, it's a function of x. So I'm going to take y equals 10/3 x squared. I'm going to divide by 10/3, so x squared will equal 3/10 y, and then I'm going to take the square root. So x will be the square root of 3/10 times y. That's the function of y I'm going to use in my formula, so I can set up my volume now. It will be pi, the integral from 0 to 1.2. This y value is 1.2. And the radius is this x value, which is this. Squared dy. That will give me the volume of this solid. Simplify first. So when I square that, it just cancels my square root. I'm going to move the 3/10 outside, so that will be 3 pi over 10 times the integral of y dy. Which will be 1/2 y squared. So it's going to be 3 pi over 20, and it'll be 1.2 squared minus 0 squared. I don't want to leave this exact because we're going to have a decimal in there. So I'm going to calculate this on my calculator, and I get 0.679. And it's in meters, so my volume will be cubic meters. So again, and just another example of a question that you might see where you have to come up with the graph and the function. So hopefully this will help you tackle those kinds of questions. There are other techniques for finding volumes. So the next one that we're going to take a look at is the washer method. And when you're ready, take a look.